My name is Stephen Morris and I'm the founder and CTO of n-eos. I'm going to introduce you to our n-gauge metrology system, which is a unique and revolutionary tool for characterising thin film coatings and membranes on many different types of samples in a range of different industrial sectors. With the n-gauge you can measure the film thickness, but you can also measure its refractive index directly, and that's useful because the refractive index is very often correlated with the material properties. If the sample is under strain, which is often the case if it's a polymer film or a metal oxide, then you can measure that strain directly via the birefringence of the material. And if the sample is curved or tilted, then not only will the n-gauge still give you the right answer despite that tilt or curvature, but it will also enable you to measure that tilt or curvature directly and so learn something about the actual sample morphology. In the next couple of minutes, I'm going to show you how it works, so let's take a look. This is what an n-gauge system looks like. The n-gauge is this blue box which sits on top of this conventional optical microscope. The n-gauge contains all of the optics and electronics which are necessary to acquire the data, and it just sits on top of the microscope where the microscope's own illumination system and eyepieces would normally go. We can support several different models of industrial microscope, and we can supply an n-gauge matched to a microscope of a customer's preference. At the back of the n-gauge, a single Ethernet cable connects the n-gauge to an external computer which provides the graphical user interface and the data processing capabilities which turn the raw optical data into measurements. In this example, I've got the n-gauge focused on a cardiac stent. Inside the n-gauge there are in fact two optical systems. There is a white light imaging system which enables you to inspect the surface of the sample just as you would with an ordinary optical microscope, and also the laser interferometry system which makes the measurement. There are many types of sample which we could have demonstrated on the n-gauge. In this n-gauge here, I'm focused on a cardiac stent. With a cardiac stent, we can easily get our submicron laser spot focused onto the strut of the stent, and the white light imaging system will help us to locate the laser spot properly and also to check the surface quality of the sample before we start doing our measurement. I'll show you how we can use the n-gauge to align the laser spot on the sample, and then how we can acquire and analyse the data in order to measure the parameters which we want to get. Here we have the n-gauge focused onto the strut of the stent. You can see the white light image of the stent strut itself, and you can see the laser spot in the centre of the screen. And up here on the top left hand corner of the screen, I've got a button which I simply press. When I press it, the n-gauge takes charge, does the data acquisition, does the analysis, and reports the results to me on the screen. If I want to have a closer look at what's going on, I can move to a different screen and I can actually see the concentric fringe pattern which the reflectometry system has gathered. Essentially, the more fringes there are, the thicker the film is, the higher the amplitude of the fringes, the greater is the refractive index. Once the measurement is complete, the n-gauge holds the results in memory, and every measurement is time-stamped so that there's a record of exactly when it was made. The data can then be exported into a standard file format such as CSV or XML, and it can be analysed offline, or it can be imported into a laboratory information management system or factory automation system, and therefore it can be used for process improvement, for process control, for regulatory compliance, as well as general research and development purposes. So with the n-gauge you can measure a wide range of different samples for many different applications in R&D, production and in academia. If you want to know more, please visit our website or contact us on this number. We look forward to hearing from you.